All right, y'all, Mr. Kowalczyk here, Unit 10, Lesson 9. Today we're going to do the law of sines. And this deals with finding side lengths or angle values using the law of sines. And then also application problems for non-right triangles using the law of sines. So we're doing side lengths and angle values for using the law of sines. So today's big opener deals with the sides of a triangle, A, B, and C. Find the sine of angle A and the sine of angle B in triangle ABC. So if we look at this, what we're allowed to use is side X, A, and B. And what we're asked to do is to find the sine of angle A and the sine of angle B. So here what we can do is we can break up the bigger triangle so that we have a right triangle in order to figure out where the law of sines comes from. So again, the sine of B and A is going to be equal to the opposite over the hypotenuse. Now, if we look at A, the opposite side is going to be X and the hypotenuse is going to be B. So that means that the sine of A is equal to X over B. Great, that's all we need to solve for. The sine of B is equal to opposite is X over A in that situation. All right, cool. Now we did that. Now we're being asked to solve for X in each of the sine equations above. So here, the way that I'm going to solve for X, to isolate X, is by multiplying by B on both sides. So I have B times the sine of A equals X over B times B. These are going to reduce to 1, and I'm left with X equals B times the sine of A. And then over here, I'm going to do the same thing, but I'm going to now multiply by A on both sides. A times the sine of B equals X over A times A. A is going to reduce to 1. X is going to equal A times the sine of B. So using these two equations, what I'm going to do is I'm actually going to go down into this why it works section here. And I'm not going to tell you what the law of sines is first. I'm actually going to show you how we can arrive at the law of sines in order to understand it. Okay, now, again, the whole idea with the law of sines is we're trying to figure out why and how we can use trigonometry with non-right triangles. So we started out with a non-right triangle, ABC, the big one, but then we dropped an altitude down here and we have a perpendicular right angles right there. So we split this up into two right triangles, and now we're using the information that we solved for in order to determine the law of sines. Now, we see that this is equal to X and that's equal to X. Therefore, by substitution, B times sine A is equal to A times sine B. So we could say X equals X, X equals X, and then we can substitute in and say B times the sine of A equals A times the sine of B. And what I'm going to do here is I'm going to try to get my A's and B's together. So in order to do that, I'm going to divide this by A, divide this by A. These A's reduce, and I'm going to be left with on this side, the sine of B is equal to B times the sine of A over A. Now on this side over here, I'm also going to divide by B and by B over here. Then these B's are going to reduce, and I'm left with the sine of A over A is equal to the sine of B over B. Okay, and this right here is how we get the law of sines. So we're going to take this, and before we move over into our law of sines, I just want to label a few things and make sure you all know that we're talking about the same stuff here. So A and B and C are the sides of the triangle. So down here, these are our sides. And then the sine of angle A deals with the angles A and B and C. These are angles. So that up here, we're going to have our angles here and there. Okay, so when we write our law of sines over here, we're going to have our angles up top first and our sides A, B, and C down on the bottom. Law of sines tells us, just like over here, that the sine of A, of angle A, is over A is equal to the sine of angle B over B, which is also equal to the sine of angle C over C. Now, as we learned before in our proportions, we can also just flip these with the reciprocal law of proportions. And because this is an extended proportion, we can just do that. So we can also write the law of sines with the angles on the bottom and the sides on the top. They both work. Okay. So we have A over the sine of A equaling B over the sine of B equaling C over the sine of C. And these two here, I'm going to box these so they don't get confused. These are the law of sines. Okay, either of these work, angle on top or angle on the bottom. Okay, cool. So that's the law of sines. Now, how do we use that in particular problems? Let's solve a couple. All right, flipping over. Let's take a look at our first one here. We've got triangle ABC, and we're being asked to find BC. So BC is over here, and A is 33 degrees, B is 105, and B, side B, this is a lowercase b, so it's going to be side B, is 37.9. Side B is across from angle B. Yeah. Okay, and we're asked to solve for side BC. Now, with the law of sines, we said we were using uppercase letters for angles and lowercase letters for sides. So angle A is here, and across from angle A, we're just going to go ahead and call that side A, in the lowercase a. That's how we set that up. So steps to solve. After we labeled everything, 1, find the opposite pair you know, meaning what's a pair, an opposite set of pairs, an angle, and a side where I have all of the information. Okay. Now, identify what you're solving for. That's going to be A that I'm solving for. This is my second opposite pair that I have here, an angle and a side. Put that in the numerator of the law of sines. So A is what I'm solving for over the sine of 33 equals, actually, let me back up. I'm going to write out my law of sines before I do that. So my law of sines is going to be A over the sine of A equals B over the sine of B, right? We write out the rules to help ourselves remember them. Okay, now A, I don't know, over the sine of A, which is 33 degrees, equals B, which I know is 37.9, divided by the sine of 105. Okay, that's 33. Now, I've got my proportion. I cross multiply to solve. So I have A times the sine of 105 equals 37.9 sine 33. Now, I'm trying to isolate A here. So the way I'm going to do that is by dividing by the sine of 105, which is just a decimal number. And then going this way, A is going to be approximately, we use our calculators for this. So check it out. I'm going to plug this into my calculator where I get 37.9 sine 33. And then I find out what that is. Now I have to divide that by the sine of 105. And that's going to give me 21.36, which rounds to 21.4 because the 6 tells the 3 to go up. Okay, 21.4. Awesome. Okay. So now let's do one more together. And what I want to do is want you to work on number 5. In triangle RST, RT is 11, ST is 18, and the measure of angle R is 120. To the nearest degree, what is the measure of angle S? So I want to do this because now we're solving for an angle, not just a side. So I'm going to draw a triangle, and I have to maintain a mindset that this triangle is not to scale. I'm just drawing any old triangle, so I'm going to now label what I know. RT is 11, ST is 18, and R is 120. Now clearly, this angle is not 120 degrees. So just forget about the scale factor in these particular problems. Okay, if it's important to you, then you could draw a triangle that has an angle that looks like 120. But for me, I just kind of draw any old triangle and solve for what I know. All right, now to the nearest degree, what is the measure of angle S? Now angle S is over here. That's going to be my unknown angle. Now before we said our rule of sine is going to be A over the sine of A equals B over the sine of B. But in our problem solving steps, it told us to put that in the numerator of the law of sines. So here we're solving for an angle, angle S. So in this case, we're going to flip the law of sines over and say that the sine of S over side S is equal to the sine of angle R over side R. All right, so let's go ahead now and plug in what we know and solve for what we don't. So we have the sine of theta, or S, over side S, which is across, which is 11, equaling the sine of 120 over side R, which is 18. Okay. Now we have our proportion, we cross multiply and solve. This one's going to be a little different because we're solving for the angle, so let's be careful. We have 11 sine 120 equals 18 sine theta. All right, now I'm trying to isolate this theta, so I need to divide by 18. So then what I'm going to be left with, I'm actually going to come over this way, is that sine of theta is equal to 11 sine 120 over 18. Now, I'm solving for this, so I have to use my inverse trig function, which tells me that theta is equal to the inverse sine of 11 sine 120 over 18. And I just plug this into my calculator to solve for theta. All right, so we do inverse sine. You know what? In order to avoid any problems with parentheses, I'm just going to go ahead and solve for this number inside the parentheses first, and then take the inverse sine of that. So 11 sine 120 equals that. I divide that by 18, and I get 0.52 with the decimal. Now I go inverse sine, and I can use my answer function in order to use this number right up here to solve for the angle measurement that is that degree. All right, so that tells me that I've got 31.95. The 5 tells the 9 to go up to 10, which tells this to go up to 32.0. So we're rounding to 32 degrees. Okay, so this is a little bit different, but just be careful when you're solving for theta in terms of evaluating the number inside of the parentheses first. Okay. All right, we'll practice these in class, and hopefully you can. This video was helpful. We'll see you later. Adios.